Hi, good day everyone. My name is Alex. Thank you so much for taking the time to attend our webinar today, specifically focused on the Ubiquiti VLAN setup methods. Very much a technical webinar focused on how we're going to set up VLANs within the Ubiquiti interfaces, the types of VLANs that we can set up, and how we're going to handle the different components around it. So very much a technical webinar. A lot of the technical topics tend to overlap with each other, so this is just the first of many. We'll go into a lot more depth around some of these topics as we continue on through our webinar series, and we're going to do much more webinars around topics like firewalls, etc. as well. As always, suggestions most welcome for any of our webinar content. If you want to see us discuss any specific topic, please feel free to send an email to webinars@leadersystems.com.au. In the video today, on the videos that we set up, the device I'm using is a UDM Pro AC, just for your own information, although the device interfaces should be pretty universal across the different Ubiquiti products. So with that being said, we can delve straight into it. It's not a product-focused webinar at all. So first and very quickly, we're going to take a look at what VLANs are. So I think most of you already know what a VLAN is, but just as a very quick overview, a VLAN is essentially a way to logically separate your network instead of physically separating networks. So for example, you can have multiple devices on the same physical network, but you don't want traffic to potentially overlap and interfere between devices. So like VoIP traffic, for example, and regular data, you would ideally like to keep them apart from each other, and VLANs are great for dividing a single network into multiple non-overlapping networks. So the reason we need VLANs is to keep traffic separate from each other so that we do not, for example, have a large download flooding a voice network as example, and then essentially degrading the quality of that service. We also use VLANs for security to restrict users or devices from accessing other devices on the same physical network, and we can use it to prevent access to network devices for users that are not supposed to reach them. So let's take a quick look at the objective for today's webinar. So first things we're going to do is we're going to build four distinctive networks. The first one is a corporate network, and then we're going to build a guest network as well as a camera network and an IoT network. This is a very reminiscent of a real world deployment. You'll very often come across scenarios like this. We're also going to segment these networks via VLANs. We're also going to do radius-based VLAN assignment. We are going to talk about radius authentication in a lot of depth in some of our future webinars as well, just FYI. And we're also going to show you inter-VLAN routing as well as inter-VLAN blocking and a basic setup of port groups and firewall rule setup. So with that being said, we're going to delve straight into it, and we're going to start off by looking at the network and my topology. So the topology I have right now is I've got a UDM connected to a USW Pro 24 switch, as well as a UAP AC SHD, and I've got my notebook connected up to the switch directly, as well as a G3 dome. And we're going to separate out our networks accordingly. So by default, we have a network in place already, and it's typically called the default network. I've just renamed that to a corporate network for simplicity's sake and for recording this video. And essentially what we're going to do through our setup topology today is just look at how we separate out these devices from each other. So let's start by taking a look at what I've got set up. So that's my topology, and what I'm going to do is I'm going to go to settings. You'll see I've got my corporate Wi-Fi in place already. That's just the default one that I've renamed. I've got my default network set up already as well. What I'm going to do as a starting point, I want to create a guest network. So to do this, I'm going to first create a bandwidth profile, and I would typically put this in place for most networks. A guest network, for example, I would say it's limited to 5 and 2 megabits per second respectively, whereas my corporate network is not as restrictive, but it depends on what you want. In the profile section as well, we can set up the guest hotspot for authentication purposes, and this will essentially function as a walled garden. We set up restrictions in terms of what they can access, and Ubiquiti is very intuitive with the way this is done. The next step is to actually go create the network. So the network in this instance is going to be called guest network. We're going to use the UDM as the primary router, And what I'm going to do is I'm going to separate out my network. So I'm going to make this 192.168.20.1. That is the IP address of my primary or of my gateway that I'm going to assign to this. And for the VLAN, I'm just going to make that 20 as well. And I'm going to select guest network. So Ubiquiti automatically apply a lot of restrictions when you're selecting guest networks. And I'm also going to select work as my guest network type. So when you're setting up a guest network for the first time, Ubiquiti will automatically add rules into place to make sure that those guests can't access the rest of your network. That's the difference between a default network and a guest network. Now I'm essentially creating the SSID for this network. I'm going to call it just very simply guest Wi-Fi. The password in this instance is superfluous. We don't need to worry about what that is because we want our guests to authenticate to a walled garden. The network there I've selected as guest network, and that is extremely important. And then the Wi-Fi type as well has to be guest hotspot. This essentially all it does is it puts all the rules and restrictions in the firewall in place so that your guests cannot access content they're not supposed to or devices they're not supposed to. The bandwidth profile I've used as well is the guest one that I've created. For our guest network, we typically don't want to set up WPA. We'll instead use open because we want our guests to be able to establish a primary connection, reach our walled garden, and as soon as they've hit that walled garden, be able to authenticate with the password that we see in the hotspot section. So really simple and quick to set up a guest hotspot and a guest network as well as guest VLAN. In this scenario, I've essentially said my guest VLAN is VLAN 20. All my guests should connect to that VLAN by default. I'm going to do the same thing for my IoT network. Essentially, I'm going to go create a network. I'm going to go create an SSID. I'm going to go again create a port profile as well. So to do this, first thing I'm going to do is you'll see that my corporate and guest network is still in place. First thing, similar to how I did it before, I'm just going to go to the profile section, set up a restriction to 1 megabit per second. We want our IoT devices to be to have limited bandwidth availability for security purposes. And next thing I'm going to do is I'm going to go create this network. I'm just going to call it IoT network again. And similar to before, I'm going to detect auto scale. I'm going to give this a IP address range. So my gateway will be on 30.1. I'm going to go manual. I'm going to make my VLAN ID 30 as well. So this means my VLAN in use for my IoT network is VLAN 30. Add the network. And similar to before, I'm again going to go add a Wi-Fi SSID as well. So this is me just adding that in. So create guest SSID, IoT SSID. So I'm just calling it IoT Wi-Fi network. The password here can just be a straightforward, simple password. I'm selecting the network as IoT network, and I am making this a 2.4 gigahertz network only. So bandwidth profile, IoT profile, I'm just going to add this Wi-Fi network, and it's going to start broadcasting that SSID as soon as that's done. So why do we do this? Why do we restrict out IoT devices, and why do we want to keep them separate? Well, primarily it's due to the untrusted nature of IoT devices. I don't know about you, but I typically don't trust devices from manufacturers that I don't know. And a lot of your IoT devices are typically come from origins that we don't know. They're from manufacturers that we don't know. They use firmware that we don't really know or aren't familiar with, and they have lots of uh, access set up to reach their servers internationally, etc. So they potentially can cause a lot of harm, which is why we're very restrictive on IoT devices. So the last one I'm going to do here is I'm going to create a camera network. So with the camera network, I don't need to go set up an SSID. I just want to have my cameras connected via the switch. I don't need to set up a bandwidth profile either because I want my cameras to function as fast as they possibly can. So in the network section, I'm going to go cameras. I'm going to give this a camera network name. I'm going to say, again, auto scale detect. I'm going to make this in the 40 range, and my VLAN ID as well is going to be in the 40 range. I don't need to make this a guest network. I don't need to apply content filtering or anything like that. And we've now effectively added this network in the same as we did for the others. So next thing we need to go do is actually assign the networks that we've created to a specific port profile or to a specific port on the switch. So to do this, what I'm going to do first is I'm going to show you that my access point, my notebook, and my camera is connected to the switch, and they're all in the default range. I can test this by pinging devices as we're all across the same network. What I'm going to do now is I'm going to go onto the switch itself and go to the port manager, and I'm looking at the port that the camera is physically connected to. In this instance, it's port 2. First thing I'm going to do here is I'm going to give this port a name. So I'm just going to call it an IP camera, just so we can keep track of it later on. And now I need to assign the port profile. It's a camera, so I'm putting it onto camera network. Then I'm going to go apply changes. And if I go ping this device, you'll see that it takes a couple seconds for that port profile to be applied to this device. So you'll see it's connected, connected, and then disconnected. It's now applying that port profile, which means it's changing to the correct VLAN that the device should be in. So the VLAN it should be in is in the 40 range, and the network range should also be in the 40 range as well, obviously. So it's now theoretically connected to the correct VLAN and connected to the correct IP address range. So we can verify this by pinging that device to make sure that it's hopped to the correct network accordingly. So again, looking at my topology, I can now see that my IP address as shown is 192.168.40.228 for the camera, and I can ping that. But you should notice something here, that my PC is not part of the same network. My PC is still on 192.168.1.131. So that is a different subnet. So the reason for this is because my PC is it's going through the UDM, which is doing the inter-VLAN routing. What I'm going to do now is I'm going to put my PC into the same VLAN range. By doing that, I'm essentially going to camera network, apply that to my port, and that's the port that my PC is on right now. And I'll again keep pinging the camera until it disconnects. You'll see it takes a couple seconds. There we go. It's now disconnected from the camera, and that's because it's busy applying the correct VLAN and IP range to my laptop. What I can do is I can see what my IP address range is right now. It's still on 192.168.1.131, and that is due to my IP lease period. So my IP is still being leased. My PC hasn't changed. So I'm going to force that. I'm just going to go ipconfig release and ipconfig renew. And essentially it's renewing my IP address. And as soon as that's done, we should see that I can again reach the camera because I'm now part of the same and correct network. So I'm now on 192.168.40.131 as my own IP address, and I can ping 40.228 as the camera's network, or camera's address as well. Similarly to before, I can again see that I can still reach 192.168.1.1, which is my primary gateway, which I may not necessarily want. It means my device can still reach other devices in the network. And I can take this a step further. I can even still reach my UAP ACSHD, which is on a completely separate network. So theoretically, I don't want that to happen, but it depends on what your setup topology is. My network or my device, for all intents and purposes now, is on the camera network. The camera is on the camera network, and the traffic from my camera network will theoretically not interfere with the rest of my networks, but the other devices can still reach, or I can still reach other devices on the network. Let me put it that way. So we need to create rules to get past that. This is via a wired connection though. So let's say I don't have a device that is wired. Let's say I want to connect wirelessly to this network, but still receive my correct VLAN ID. And the way I would do this is basically through radius authentication. So what I've done in this instance, I've disconnected my laptop. It's no longer connected physically to the switch port. I'm going to connect to the UAP instead, and I'm going to use radius authentication to get the correct VLAN. So to do this, you'll see my topology as indicated. To do this, I'm going to go to settings, and I want to connect up to the corporate Wi-Fi via radius server mode. So I'm going to go to profiles. This is the radius server profile that's built into the UDM Pro. I'm going to go assign this to our wireless network only, and I'm going to go create a user for this as well. So I'm going to make it just Alex, give him a simple password, and I'm going to give this user a specific VLAN ID. In this case, I wanted to reach the camera network, which is 40, so I'll give it 40. I need to use a couple of specific parameters here. Specifically, I need to use tunnel type as virtual LAN, and then the tunnel medium type as medium type 6, and that's basically called the conical format. We go into a lot of depth around this in the webinar on firewalls as well. So I've now applied that, I've created a user, and anyone that uses that username and password will essentially go onto the correct network and connect to the correct VLAN. So I'm going back into my corporate network here, and the big thing I need to do before this actually becomes applicable is I need to go change my security type to WPA2 Enterprise, because WPA2 Appreciate Key, or PSK, does not allow radius authentication. We're going to give this a couple of seconds to provision through, and it should come up in a sec saying it's completed, and we can then authenticate from our laptop to the UAP and show that it's correctly fetching the correct network as well as the correct VLAN credentials. So we'll see it's done provisioning now. On my laptop, I'm just going to connect to the corporate Wi-Fi. I'm going to give this a username of Alex and then the password that I've set up. I'm just going to go OK and connect as I normally would. As soon as that's done, we should now see that it's fetched an IP address that is in the camera network's range. So let's see, ipconfig-all, and I should see my wireless card here. There we go. It's indicating an IP address of 192.168.40.120. So it is connecting to the correct network. But again, I can still see that I can ping 192.168.1.1, and I can still ping other devices on this network as well. We'll see that my laptop's now connected to the UAP SSD, but I can still, like the cameras, I can obviously hit because I'm in the same network, but the UAP, for example, because it's in a different network, I shouldn't be able to hit it. This is again due to inter-VLAN routing, which is set up by default or which is happening by default. So that's all working. If this is your intention, then essentially you're done. A lot of people don't bother with setting up blocks between the different VLANs, but for devices like cameras and IoT devices, I would typically recommend restricting what they have access to so that you don't end up with a scenario where they can reach other devices on your network. So let's take a look at how we would join the IoT network that I've set up. I've got my laptop already connected to the UAP via the radius authentication that I've set up before. And essentially what I'm going to do now is I'm going to go onto my cell phone and I'm going to connect that up as well just via the IoT network. And you'll see my phone comes up there. And now it's essentially just connected by using the correct username, oh sorry, just the correct password, and it's connected up to the IoT network just like any other device. So through this, we can say that we have two ways to connect to the correct VLAN. One is via SSID. We can create a new SSID for every VLAN, but that's obviously a bit limiting because we can only have up to 8 SSIDs. So really what we should be doing instead is looking at radius-based authentication, because it's a more efficient way to correctly assign users to the specific network profile that they should be in. The other thing as well is that if you're creating more SSIDs, you become less spectrally efficient, as Ubiquiti terms it, which just means that you're wasting a lot of airtime and your devices aren't as efficient as they possibly can be. So let's assess what we've done. So right now what we did was we built 4 distinct networks. We built a corporate network, a guest network, a camera network, and an IoT network. We have segmented these networks via VLAN. We have set up radius-based VLAN assignment. We've shown that inter-VLAN routing still works because we can hit different gateways even though our devices aren't in them, but we haven't shown blocking just yet. What we're going to show next as well is how port groups and firewall rule setup would work. So we're not going to work through every firewall rule here. We have a separate webinar coming up for that. What we'll be showing instead is the basics of blocking inter-VLAN routing. I've gone and set up a couple of rules already, as this takes a bit of time to get going, but it's really pretty easy to understand. The first two rules that I've set up was just basically on how to handle existing state connections as well as invalid state connections. So this is just a precaution. I'm not going to cover this in depth. Instead, we'll just be looking at the rules around how to block VLANs, etc., etc. So the two rules that I've predefined is, I'll highlight them here. So allow established related session and then drop invalid state. So that one, and then drop invalid state as well. So there we go, drop invalid state. What I'm going to do now is I'm going to navigate to the rules that I've set up to block inter-VLAN traffic, and I'm going to show you how this is done. So the first one that I've set up is essentially the most important rules that we don't block ourselves out of this. So this is the first rule that I create, and essentially it says allow main VLAN to connect to other VLANs. So anything that connects to the default network, I want it to be able to reach anything on the rest of my network. So I'm just saying that if I connect a device to switch port 9, for example, it should be able to reach all the other VLANs so that I don't lock myself out of the switch. So very simple rule to establish. I've also created a port profile here, and it's basically just saying that if I connect via LAN in, it should accept the traffic. When the source is the default network, then the destination is not private IP address range, then it should allow that connection. So that's nice and easy to understand. We've also set up a rule to block VLAN to VLAN traffic. This isn't all we need something else as well. But what we're doing through this is we're blocking private IPs from reaching other private IPs. So if LAN in, the network type is LAN in, essentially it should drop the traffic when the source is a private IP and the destination is a private IP as well. So that's that private IP group that we've created. So that's one of the rules we need to set up. And then the next rules we need to start setting up is to block our IoT access to different gateways. So I want to say that devices on my IoT network should only be able to reach its own gateway and not gateways from, for example, the camera network or something like that. To do this, we're using LAN local, which means traffic from our device to the UDM. We're going to say the source type is the IoT network, and we're going to again use a port or IP group here, which I'll show you in a second. So if I go to profiles, my gateway. So essentially what I'm doing is I've created a group that says if my device tries to hit 192.168.1.1, 40, 20, it should essentially not be able to do it. Those are the gateways for the other VLANs that I've set up. And this rule basically precludes this device from hitting those devices or those gateways. So the next one that I've also created here is to block IoT devices from accessing my UDM's interface. So I'm essentially saying drop all traffic if the network source type is our IoT network and the destination type is a specific group again here, port group specifically. So we're going to say our port group is HTTP, HTTPS, and SSH. This is another port group that I've created. So, and this is very simple again. Just going down to the port group that I created, which is okay. So this rule does two things as well. So the second part of it is it prevents obviously the device from hitting the UDM or seeing the UDM, and then it blocks those specific port numbers. So those are the port profiles that I've created, and essentially both of those port profiles are applied at the same time. So I'm restricting it so that it cannot reach my UDM. So it's saying it cannot reach it on ports 80, 443, or 22, and I'm also saying that it cannot reach IP address 192.168.30.1. Okay, so there we go. I've set up the different ports. Now I'm essentially going to have to do the same thing for the camera network as well. So it's literally just a repeat of the same steps, and it should essentially come to the same conclusion where we've blocked access for your cameras to not reach any gateways outside of their own network, and they should also not be able to reach the UDM's interface, and they should not be able to do any inter-VLAN routing, essentially. So we can test these rules, and I'm essentially going to function or put my laptop into the function of either as a camera or an IoT device, and we're going to see how these rules play out. So you'll see the rules are active. I've left all of my rules on exactly as is. For an in-depth discussion around these rules, you are welcome to reach out to us as well, and we'll try to guide you through the setup. But essentially what I'm going to do now is I'm going to go to the topology. We'll see that I've got my laptop connected directly to the switch. I've got my cell phone connected directly to my access point. I'm going to show it there. There we go. It's part of the IoT network right now. Although my access point itself is still connected to the primary network, my default network. And then lastly, my camera, which is on 192.168.40, so it's within its own network as well. So what I'm going to try and do is take my PC and jump between ports, so I can jump into the IoT network and jump into the camera network. This is the port I'm on right now, port 14. You can see my camera is on port 2 still, and it's still got the camera profile. I've set up two separate ports here. Port 5 is a camera network port, and port 6 is a IoT network port. So if I go take my laptop and physically connect it into any one of these ports, it will hop into that range respectively. We'll see that my address that I'm connecting to locally is the gateway that I'm on, is the UDM 192.168.1.1. So as soon as I physically disconnect my laptop and connect it to one of these ports, I should essentially lose connectivity to the gateway and only be able to hit everything on my own network, my VLAN network, assuming my firewalls are in place. So because I'm still connected to port 14 right now, you'll see I can reach everything, which means that inter-VLAN routing is working as it should. There's no blocking, and that's partially due to that rule that I created that says if I'm on the default network, you're able to reach everything local. So I can ping everything, I can ping cameras, I can ping the cell phone, I can ping everything from here. So it means all inter-VLAN routing is still doing what it's supposed to. What I'm going to do in a second here is I'm just going to disconnect this, and I am going to hop onto port 5. So I've now physically connected to port number 5. We should see my port or my access to this gateway stop in a second. It should time out. And if I bring up ping, I should now only be able to hit stuff in my own network, which is the camera network. So if I try to ping 192.168.1.1, it doesn't reach it. And same thing for everything outside of my network, it will not reach it. If I try 40, so 40 is the correct IP address range. That's for my camera network range, and I can reach my own gateway like I should be able to. If I try to reach the IoT gateway, that rule is blocking it from happening. So essentially all other access for everything apart from devices within my own local network is functioning the way it should. So if I go take this a step further and connect up to the IoT ports, I've essentially just disconnected my my physical cable and connected it to port 6. Again, my gateway, the 192.168.1.1, is not reachable. But if I try to now connect to the gateway I was on previously, or the range that I was on previously, you'll see it again times out. That's because the rules are in place and they're working as they should. I can't hit the gateway, I can't hit the devices. I'm in the IoT network, and now I can ping all the IoT devices. So I can ping, for example, the gateway, and I can ping other IoT devices on this network. Sometimes, like my cell phone here doesn't have the perfect connection, so it's not going to reach that destination instantly, but if I keep trying, you'll see it does hit that. There we go. It does hit that device eventually. So again, inter-VLAN routing is now blocked, and it is essentially restricting all IoT traffic to only the IoT network, all camera traffic to only the camera network. That's simply done through the firewall rules that we've established. So that's a very quick overview of the VLAN setup. What I would recommend as well is checking out any of Ubiquiti's training sessions. We do have classes coming up throughout the entire country for pretty much the rest of the year. So please feel free to hop onto any one of those classes. We do discuss VLANs in a fair bit of detail as well in class, and we are happy to discuss that topic further if required in class as well. In terms of the webinars, so Leader does have a ton of other webinars coming up throughout the rest of the year. Please feel free to register for any one of them. We have tons of great info and awesome prizes to give away as well. And then lastly, just to register, you can obviously go on to leaderacademy.com.au and you can register for any one of the classes or register for any one of the webinars from there. With that being said, we are now going to jump into the Q&A. And for those of you watching this on YouTube, I'd like to thank you for your time. Thank you for watching this video. And we do look forward to seeing you in one of our future webinars.